The presentation is mainly of structural equation modeling, SEM. The members of the group. With the chosen topic is Introduction to Structural Equation Modeling, SEM. Content. Introduction to SEM. What is SEM? SEM is a general statistical modeling technique used to establish relationship among variables. SEM is a confirmatory data analysis technique. It tests models that are conceptually derived. It tests if the theory fits the data. SEM can be thought of as a combination of factor analysis and multiple regression. It is alternately defined by the following terms as below. Covariance, at the heart of SEM. Covariance is a measure of how much two random variables change together. Alternatively, it can be defined as the strength of association between the two variables and their variabilities. Logic of SEM. Every theory implies a set of correlations. Necessary condition for the validity of the theory is that it should be able to reproduce the correlations observed. Next is uses of SEM, which consist of 1. Theory testing. 2. Tests of indirect effects. 3. Group differences. 4. Longitudinal models. 5. Multi-level nested models. History of SEM. History of SEM. SEM was laid with the development of Spearman's work the early 20th century. He trying to trace the various dimensions of intelligence back to a single factor. In 1930s, Thurstone developed multi-factor analysis and bestowed the gift of factor rotation on the statistical community. Around the same time, 1920s-1930s, Wright developing path analysis, which relies on manifest variables with the ability to model indirect relationships among variables. In addition, in 1950s econometricians saw what Wright was doing and the SEM evolved. In 1970s, Jorskog combined the measurement powers of factor analysis with the regression modeling power of path analysis. The factor analysis capabilities of SEM allow it to assess the accuracy of the measurement of the model. The path analysis capabilities of SEM allow it to model direct and indirect relationships among latent variables. There are many different software available for conducting SEM analysis, for example, LISREL. AMOS, next, is linkage between CFA to SEM. Confirmatory factor analysis is a powerful and flexible statistical technique focusing on modeling the relationship between manifest indicators and underlying latent variables. CFA is a special case of SEM in which relationships among latent variables are modeled as covariance or correlations. SEM, in comparison with CFA, encompasses two components. A measurement model. B, a structural model. Are there any assumptions that need to be fulfilled before using SEM? Yes. 1. The presumed cause, X, must occur before the presumed effect, Y. 2. There is association between X and Y. 3. There is isolation of the covariance between X and Y, such extraneous variables that may affect the Y. 4. Normally distributed data. 5. The direction of causal relation is correctly specified. Next we proceed with the advantages and disadvantages of using SEM. Firstly, we explore the advantages of using SEM. 1. Validity. SEM allows to make use of several indicator variables per construct simultaneously. 2. Reliability, measurement error. By explicitly including measurement error variables that correspond to the measurement error portions of observed variables. 3. Complex models. SEM allows to model and test complex patterns of relationships. 4. Confirmatory approach. SEM allows to test complex models for their compatibility with the data in their entirety. Next we explore the disadvantages of the SEM. 1. Model identification. SEM is not based on raw data as input information, but on the empirical covariances of all indicator variables. 2. Estimation methods and estimation problems. This happens where assumptions of the respective method of estimation are violated and/or have wrong assumptions. 3. Assumptions, small sample size and non-normal distributions. Combining this can lead to estimation problems and unreliable results. 4. Interpretation of results. The decision problems can occur in cases when there are two or more model different assumptions in relation to variables' causal relationships, in real-world application. In real-world application. The article in 2012 represented the SEM used in forest management by Lamb and McGuire. The study demonstrated the overstory-understory relationships which showed a direct negative effect of light attenuation on late seasonal herbs cover but a direct positive effect of northern aspect. Figure 1 showed an example of a hypothetical path model for abundance of a small mammal species in mature forests. The second research article highlighted the SEM applied in social sciences and engineering, and recently there is reported a lot in industry applications by Systematic Article Review. This article reports a strategic planning, logistics, production process, industrial safety and ergonomics, performance, decision-making and environmental impacts pertaining to the industry. Finally, the third SEM method is identified in ecological studies published in 2016 done by Fan et al., the study measuring variables related such as climate change, ecosystem structure and/or composition, resistance and resilience, and ecosystem service, can pose a problem particularly for ecological research. As a conclusion, structural equation modeling, SEM, had tremendous evolvement and applications in research study over the years. The use of SEM mainly to identify the direct and indirect relationship among causal variables with latent variables. This is the references. Thank you.